Hello and welcome to Deep Learning Leaders. My name is Eric Landau and I'm the CEO and co-founder of Ncord, the data development platform for AI teams. I'm thrilled to be joined today by Anton, the founder of Lovable, where they are building software that builds software. Thank you for joining me today, Anton.
Hey, it's a pleasure, Eric. I love that you have been a long time in deep learning, and a pleasure to talk.
Yes, I've been around the block as you have. I actually wanted to start because we have quite a bit to cover, I suspect. But I wanted to start with your time at CERN because I noticed that you
Oh,
spent some time there. And in my previous life, maybe a couple lives ago, I was also doing physics and particle physics. So I'm curious what your experience was at CERN, or kind of what projects you're working on, and how that informed any of the things that you are building today in AI or starting a company, if there's anything that translated from that.
yeah. So CERN is very fun. It's kind of this gated community on the border between France and Switzerland, where they bring out like this 10,000 uh, top brains, kind of from the entire world, and when you live in this kind of community and you only talk to super nerdy, super smart people, so that's in general a great setting to be in. Um, I think like what you see there is that it's mostly a big engineering effort, like CERN,
Mm.
uh, and like, what you can really do some like extraordinary things when you collect very smart individuals, and that's what I've been doing at like the three AI companies I've helped build and co-founded since then. Um, I mean, you mentioned also like generally what can you take from physics to do things in the real world, and I think I'm sure you're also founder like when you did physics, you've seen this as well, where um, many people with this background they really reason from like, but why is it like this? What's the first
Hmm.
principles that kind of make companies successful, and really like reason their way to the truth rather than doing what others are doing, and that often gives you an edge because you can see possibilities that especially when the world is changing, you can see a lot of possibilities that others cannot imagine yet because you're kind of reasoning your way there rather than trial and error. And
Yeah,
I've had success there.
the power of
Yeah.
like a few whys, if you just ask a few whys in a row, you can really deconstruct quite a lot about, well, about your company, about society, about the universe. It's kind of like,
Yeah.
if you fold a piece of paper, and people don't have an intuition that if you fold a piece of paper 30 times, you kind of approximate the distance to the sun, just because like they don't understand the power of exponential. And I feel like
Yeah.
asking a why is kind of like that. You're like folding the paper once, and if you ask a few questions why in a row, then you're like really deep into the weeds of kind of the base level of your own assumptions. Um, so you did YC as well, and because you mentioned like CERN is a community of engineers and physicists, of course, and it's kind of very nerdy, and you're all talking about the same things. How does the community in CERN compare to your time at YC? Was it
Mm.
similar kind of mindset, or different types of problems that you were thinking about?
Uh-huh. Um, I think that actually there's one big difference that just stands out to me between these two experiences, and it's that at CERN um, there is there's a slower pace, and there's maybe
Mm.
more room for creativity, and I think like people get less done because there's like this processes, and you have this like existing structures with a lot of people. While at YC, everyone is hyper focused, like the work,
Mm.
sleep, exercise. That's the only thing people do, um, which I mean, on, on general gives more results. Like I think you could do that at CERN as well, in some way. I think they've done that with like some projects, and um, yes, some of the best research in AI now is coming out of more of those settings as well. Like OpenAI, they
Mm.
call themselves a startup, for example. So that was that's the biggest difference between those two. And yeah, I mean, some people argue that you get more different types of creativity when you have
Hmm.
time to think and like
Mm.
not be stressed about a red deadline. I'm I couldn't spot that difference myself, but I think that there's definitely something to that as well.
Interesting. Yeah, because my intuition would be that the urgency and the constraint actually that
Yep.
necessitates more creativity than giving time. Time is almost like the
Yep.
killer of some kind of. But you found that because people had a little bit more space to breathe, in your experience, like in the physics community, they were able to come up with more interesting ideas overall.
I didn't find that, but I'm pretty sure that that's the case for some people, like some genius level people, like Newton, whatever. He didn't have any urgency from from outside, but he just invented everything that, in classical physics almost.
Yeah, yeah. Well, he was stuck at home because of the plague, so he
Yeah,
had nothing else to do
exactly.
but think about these things. So, how did you go from the transition of you're working at CERN to starting to get into entrepreneurship, into AI? I'm curious, like what precipitated that on your
Yeah.
side.
Um, the big thing that I took away from CERN was that this is a huge waste of brain power, because there is such a you're solving such a like inelastic problem,
Mm,
where most likely you're not going to make any difference at all, even how good and ambitious you are. But there are so many important problems and interesting novel problems you can solve out in industry. So I decided, okay, I'm not gonna go do academia, which I thought I might do, and I'll go back to like I was kind of more of a hacker when I was a teenager,
hmm.
and um, I've been in Stockholm since then, most of my life, and this was actually 10 years ago. It was when deep learning revolution started, and I started reading all these papers, which was quite uncommon at the time, that you were reading like the latest academic papers published on archive in deep learning, and put together a community that then really grew super fast in Stockholm, called the Stockholm AI, with some friends. And then yeah, from there I've been working at and building AI startups.
Did you have any exposure to AI systems when you were at CERN, or was it more kind of traditional uh, data engineering,
Yes.
data analysis?
I personally was working more on the traditional algorithms. There were
Hmm,
some
hmm.
people quite close to me that were like there was a bit of a controversy, like, oh, should we do using machine learning instead of these
Yeah,
traditional
yeah,
things? And now I know it has caught on much more, definitely.
yeah. I
But,
remember the days of using Root was the software that
yes,
at least I would use,
very.
and it's software built by physicists for physicists, so it's terrible. But from what I understand is that they've started incorporating more deep learning systems and models into their analysis, and it's actually it can be quite effective. Again, I haven't been
Yeah.
in it for some time, but it does feel like a very right place for disruption for more deep learning kind of expertise. All right, so you started an AI group in Stockholm. You started thinking about deep learning systems, reading the early papers. How did that translate then into kind of building a company and making
Yeah.
a product and kind of moving from there?
Um, so, I mean, the AI things, I initially did it on the side. It was like, oh, Alpha Zero came out, and I was like, me and some friends over the weekend, we hacked together a clone, a copy of Alpha Zero. But through the community, I met the founder of a company here called Sana Labs, where first employee and like technical person there, and we created algorithms to model how students learn, to
Mm.
recommend what's the next piece of content that makes them kind of level up their knowledge the most at every point in time. So guiding you through the course content and similar, and like based on that, and like we showed that this was the best model uh, in some international competitions. Sama Labs has went on to become like 100 people startup that is a company and scale up that
Hmm.
as is growing really fast on the revenue side as well. But um, I met so founding companies. I didn't do until 3 years later, where I met my co-founder at a company called Depict AI, where we did more like pure recommendation systems in the e-commerce domain. And that's a company we went through YC. We had this go-to-market motion that was really like nerdy, stupid, simple, stupid. We go out to e-commerce companies, we tell them, we know you have maybe some recommendation systems or something that kind of works. We have actually optimized this systems that work in academia to work in reality. By looking not just at the kind of historical data, which is always quite crap, but looking at the products with computer vision and understanding the text in the products. And we will show with an A/B test on a randomized experiment that you will make more money by using our product. And yeah, since then I've been an entrepreneur and a technical leader, more scaling that up.
How confident were you when you made that assertion that it would work for any particular? Is it like more like, oh, statistically, I think it's going to happen. It's going to work for 60%. So I'm just going to say it. We'll try it, and we hope that it actually works out.
Yeah. I mean, the first one we were bold, but not that confident. But then we grew confidence over experiments. I mean, just if you look at most recommendations. And you think like, what would I as if you go to a website and you look at it, you're looking at a piece of like a t-shirt or something, then you could imagine like if I was a professional recommending something relevant here, I would be recommending matching pieces of clothing or similar t-shirts with similar fabrics and so on. And it's often like very, very random because there has been some statistical fluctuations in historical data. And then you can just see it's clear that we can make something better than this. So
how do you encode that intuition into an actual model? Did you kind of handcraft something that would make sense along those types of heuristics or rules, or did you just have a better data set and a better kind of approach to building the model that you thought would outperform like traditional statistical approaches?
Yeah, I love this question. It's there are many ways to go about this. Like, okay, you can start with just training your own models from scratch. But what I have found repeatedly works best when you're building any type of intelligent system, and this is a kind of intelligent system, is that you want to take the shortest path, so that you can repeatedly get feedback from changing things in the system. And that way you yourself as an engineer and the team builds intuition about what is the right solutions and also what does this problem actually contain, because there are all of these different edge cases and so on that you didn't think about existed in the beginning.
Yeah.
So I'm a fan of doing like heuristics that give you instant feedback. You don't have to wait for this like hours of the deep learning training to understand like what are the problems we have to solve, and then taking models off the shelf and combining them, fine-tuning them, and maybe then training something of your own when you see like, okay, this is the ROI we will get business-wise if we spend more engineering hours on this part of the problem.
Yeah,
so that's
totally
my philosophy. Yeah.
No, I'm 100% alive. I often say that the number one kind of parameter or attribute that governs success of a data science project is the length of the iteration cycle. So the shorter the iteration cycle is, the more likelihood that you'll actually be able to get something to work. And what's interesting is that that's true for machine learning and data science, but it's also true for building a product. I don't know if you have the same kind of intuition of getting stuff to users, understanding, okay, here's what they say, and then like going and quickly iterating on that as well. And if you've incorporated that philosophy in terms of how you actually put products out into the world too.
Yeah, no, I love that we have similar philosophies here. So maybe I'm jumping ahead here, but the company I'm building now is really built on this thesis that the only thing you need to build great products, I call them lovable products, is that you can very rapidly take one of your customer feedbacks or a hypothesis of what could be better in the product and change it, and then see that result. And that's really the opportunity that AI is going to bring to building products. So anyone, you don't need the perfect kind of understanding in the beginning, but as long as you can iterate fast enough, it's going to become a very amazing product. And you're going to remove all the friction and all of that. That's the most key to make a great product.
Yeah, the power of real world data is so underrated, even compared to human imagination. That like the world is a lot more imaginative than any single person is. So if you allow the world to tell you what to do, that will adjunct your ability to quickly get to great systems and great products, great models.
Yeah.
So yeah, I wanted to get into Lovable itself, and I think you started with a very successful open source project, and you created something that became very viral quickly. Can you just go through the experience of how you built the initial GPT Engineer, and what it is, and kind of the story behind that?
Yeah, sure. It's a fun story. Like when already before GPT, ChatGPT like 3.5, like the old versions, it was quite clear. Like, okay, this technology is going to move fast because we have like this. We already then saw the scaling laws. Like you can add more data, you can add more relevant data, and when I was preaching, okay, guys, like we could already start using this in engineering efforts, like create some tools to make ourselves build products faster. People were less imaginative than I imagined at the company. And then GPT Engineer was me just realizing when I was sitting with a problem, okay, I can speed this up by writing a simple tool. And then that's often the best way to communicate in an engineering team, create a proof of concept. So that's where the reason came from. And what this tool does is that you give it a simple extraction, and then it takes, maybe it reads some of your files, and then it creates a lot of files in your file system. So you can spin up new projects very simply. And I decided, okay, actually I'm going to put this out on Twitter and package it with a clear explanation of why this makes sense, and showing that it actually works and it can save you time. And that I didn't expect that there would be a huge reception from that, but it really captured the imagination of a lot of people, and it kind of started the wave of what you've seen since, and like even more orchestrated fancy demos of what you can do when you hook these LLMs up into agentic systems and so on. But I decided, okay, this GitHub project with 50,000 GitHub stars, I'll let that be a platform for experimentation, and they kind of created a community of people that has been building on that tool since. And it wasn't until a few months later, like me thinking about it and thinking about what is actually meaningful here for me personally to take it forward, that I decided I'll also start a new company kind of on this topic. And we do call our first product, we still call that first product of this company GPT Engineer, and I can explain more about that. But yeah, is it something you have used, Eric? I'm actually curious to hear from you. What's your take on all of this?
No, I haven't, but I will right after this call for sure. So I'll go to the repo. So all you did was you put the repo on Twitter, and then it kind of just took off on its own. There was no other kind of effort to promote virality or to get the word out. It just kind of had its own.
I can go into like I haven't been so big on like any growth hacks or such, but I didn't really have a Twitter following. I had more of a LinkedIn following, but I didn't post this on LinkedIn. I did ping 2 people like, hey, I just made this project. I don't have as much Twitter followers. If you'd want to retweet it, that would be cool. So that was 2 people. The mechanism of how it took off was, I think 2 things. One was GitHub trending projects, because it was on GitHub trending top list for a month or 2. And people covering this in their YouTube channels. So that's the mechanism in how this guys kept growing, and there's some resharing on Twitter and so on.
And I'm sure that you saw a ton of applications that were being built with it, or demos. What was something that you were like pleasantly surprised on, or that like a demo that you wouldn't have imagined when you kind of put that out into the world?
I think the main thing I'm pleasantly surprised by is like CTOs using this for their prototyping, to show the team whatever. Like some say that I always start with this tool, and these days, like there's been a lot of people building in the space since, and I don't use the open source tool anymore. It's kind of not really actively developed as a real software product. So I personally use other things. The GPT Engineer app, which is Lovable's first product, is what I use to create personal productivity tools, for example.
Yeah. So I'm curious.
I can explain
then,
the difference more in depth.
yeah. No, I would love to kind of understand the difference, because I think what I've seen often is people they have very successful open source projects, and then they create a company around it. But then there's some tension between the kind of open source project that's out there and their app, and sometimes they can fall victim to their own success of the original open source app. So I'm curious, like, how you kind of think about that, involve, and try to use the momentum from your success in the open source world into getting people to use the GPT Engineer app, and getting into the Lovable ecosystem in general.
So how I thought about it is, well, the way to build something useful here is to experiment, right? And this open source command line tool is something that you can easily experiment with. You can add some new features and see how well they work. I leave it at that. What I think is, like, when it becomes truly useful is when you add a more complex UI to it, not just this developer tool, because like, it's only 1% of the world that know how to create software, and it's like software is also like the big value unlock from the last few decades. So if you can create a user interface that is, we don't know what that user interface looks like yet. No one knows that yet. But if we can create that interface where anyone can build software, then you're like creating such a large unlock. And all of this, there will be a lot of new amazing products that we don't know what they should be yet created, and there will be a lot of existing products that stop being like clunky and annoying and sometimes glitchy to just be really nice, lovable experiences. And that's why we're building and the interface, so to say, to create other software.
And is the idea that you get people that don't have any software experience to build the software end to end, or that you still pair them with some kind of engineer to polish things or to run tests or whatnot, and it just saves so much time on the engineering? You can take an engineering team of 10 and make it one person. What is the main use case that you see?
Yeah. So once you go into the weeds, you notice that to start things from scratch with all like best practices and so on, these tools really shine, and that's what our tool does really well now. And to start taking it further, you have to be technical, and I would say it's enough with one engineer that's like really sophisticated to use a tool like ours today, and explain what you want, maybe add some wireframe screenshots, and explain, okay, connect to this other API, connect to this authentication, this database, and then you have a SaaS web app version 1. So that's what it does. What is much harder is when you have an existing software with all of these requirements and moving pieces, and then asking an AI to edit that, and that AI cannot do yet. So like anyone that thinks that it's going to be able to do that is going to be very disappointed. So that you really have to have the right expectations there. That is amazing for prototyping 100 times faster than a human software engineer often prototyping, and creating a simple like internal tool, for example, when you want to edit your database as an admin. It's perfect for those use cases. But when you and build up version 1 of your software, but then when you want to like make it more than, let's say, kind of 10-20 features in the product, then humans will have to be quite involved and steer the AI system more like a co-pilot.
I see. And in terms of what the application is, it sounds like it's some interface that can take LLM output and put them in a way that shapes a software repository in the right structure, and allows you to build these apps easily. Is it also that you are working on the model layer itself, and that you have your own LLM and kind of tuning it for these specific use cases, or
Yes.
maybe connect to a bunch of use cases? How do you interact with the model layer currently?
Yeah, good question. So, top down, you chat, you prompt, and you create the first version. Then you chat to do edits to it. You can show visually what you want to do. Everything is synchronized with a GitHub repository that you own, and you can edit it. And then you can do some edit yourself, and then you can ask the AI to do edits. And it can be fully like one-click deployed. The This is how our philosophy now is, like maximal experimentation velocity, so that we try things both on the UX, like what is the right interface, and what's the best models backing all of this. And our experience from having spent time on fine-tuning models and looking at training them from scratch is that the kind of advantage that you build up is going to last a few months in general, because there's so much, the commercial models that are coming out every few months, they do add such significant improvements. The fine tuning that we are looking at now is actually more just to reduce latent kind of inference times and costs, but it's not something that in the current state is critical for our product. So it's more what we're adding is the packaging and the UX for it.
And do you have some kind of guide about what kind of prompting strategies work best as well? So if let's say you're using the off the shelf, you want to have the best way to actually prompt a model for this use case.
So I can talk a long time about prompting strategies and so on.
Sure. Yeah.
But some like high level takeaways, I think is, so we spent considerable research efforts on like how can we make agentic behavior work well, and on our conclusion there is that it's very difficult to create a good user experience where the user gets fast feedback, understands the system, and can guide it, and more, not just guide it because it does a mistake, but guide it to really convey what you actually want, which is a very difficult process. That's what you spend most time on building software products. And we have since moved much more towards the return your results as fast as possible, and don't have as many steps or like chains of LLM calls or agentic behavior that we have some versions of in our product as well. And what that means is that you want to have like one default like prompt that handles the user input, and spend a lot of time and thinking about that prompt and which model you use for that and so on. And then you will have some like secondary kind of more tools that your main prompts can let the LLM decide to go into if you really want. So happy if you can ask for clarification there, but the takeaway is one large prompt that's very fast to run.
Okay, so I'm curious how you got to that prompt and what the iteration cycle was there. Maybe right before that, I want to touch back on kind of the agentic systems, because they're very hypey now. Building agentic systems and agentic workflows. Do you feel like it is just hype, or do you feel like that will actually get to work at some point? I can imagine it's quite tricky, right? Because you have a lot of things interacting with each other. They're non-deterministic. There's a lot of places where things can break and go wrong. It's difficult to debug. So what do you see as the future of these kinds of agentic strategies?
Yeah. So I'm an optimist. I'm confident they will work, and I'm quite confident that is how we get these kind of AGI level systems. What if you look at where things are currently? The big factor to decide if an agentic system is the right approach, I think it is the right approach already today in some cases, is in what way can the system fail, not do what the user wants, and what happens then? Because that's like that will be the deciding factor if this is a worthwhile thing to do. Um, and if there is always a way where it fails and the user completely understands what happens and they know exactly what to do next to make it work or to solve their problem, yeah, then an agentic system can be good. But I mostly that is not the case. Mostly, if it fails, it's quite hard. It's difficult to get the
Yes.
user to understand what they should do next. So that's how
And
that's why I don't believe in agentic systems most of the time.
yeah, I suppose I don't know if that's because we don't have the kind of practice maturity for it yet, that we have the
Could be.
frameworks of how agentic systems should be run, or if it's just fundamentally, you're always going to be playing a game of telephone with these things, and there's some percentage of noise in each step in the chain, and so like it's just fundamentally flawed for some reason. But
Yeah.
I don't have a strong
Can
view
I
of it
just
myself.
Yeah, I would like to just touch on the definition here is quite important. Like if you take Perplexity AI, which is like a search engine, it kind of does some agentic things. I usually like to refer to it as a chain, where it does some reasoning and then it does some retrieval and some more reasoning, and that UX is really good. You also understand what happens, and you can kind of interact and steer it. So that's an example where it works if you want to use that, define that as an agentic system. But they have spent a lot of time iterating on what should that UX be, and that's why it works, I would say.
Yeah, and maybe that's the framework that other people should adopt, and it just hasn't disseminated yet into consciousness when people are building these types of systems, what they should look like fundamentally, what the schema should be.
Yep.
So going back to the prompts, building a big prompt and making sure that it works and is fast, how do you do that? Like, what is your kind of like prompt iteration strategy to get to something that will work in your app generally across a bunch of different types of things that people want to build?
We are figuring that out still. It's a hard problem, and it's a very important problem. It's very fun that no one has really figured it out yet. But some things to mention that I like is, like, one, you want to be able to quickly get this intuitive feedback loop and just try and see does this make sense, and then you cannot just look at the number, but you have to look at the output and understand what types of mistakes it can do. So like that's why it's very useful not to have this long agent that does like takes many minutes to run it, but it's quite fast. So that, and people refer to that as the vibe check, like keep doing the vibe checks. Then there are two more things I think in being able to iterate on a prompt, and one is to measure your like quality in production with your actual users, and just like you have uptime and like latency checks on all your systems in a software product, you have that on the quality of the LLM or the agent or AI output. And what we're doing is that we're letting an LLM evaluate the output according to various criteria, and that in that way we can see if we do some change that we thought would be an improvement, and then it's actually that makes something else worse. So so that we can see on real user data, and then we also do that offline. So we take like a set of examples, and then before we do a large change, we look at does it improve in these various dimensions or not.
Is there any place for human judgment there? So you're using an LLM for the evaluation criteria.
Yep.
Do you sense check that LLM that's checking the other LLMs?
Yeah. So we're moving fast, and we don't like have very specific processes for doing what we have done in some cases, which is looking at how often does the LLM agree with the human, right? And in some cases, the LLM agrees better with a human than two different humans agree with each other. And that's kind of an indication that it is not so important to use a human. Right. But that's still a very something I would definitely recommend in the more especially when it's very mission critical.
Okay.
Yeah.
So one thing I'm curious about is, let's say that you figure all these things out and you're able to create an app that creates all the apps. And one thing we were touched on right before we started is you mentioned a very intriguing idea of a single person unicorn. Is
Yeah.
this the tool that gets us to single person unicorns, or is there some other paradigm shift that's necessary to think about that?
Mm. So like the internet has really given us this like 0 to 1 distribution advantage. If you make a really good product, then people will quickly learn about it, and 10 billion people almost can start using it. But to making a really good product has required a lot of labor, like human labor, right? What I think it will require more in the future is very good product taste and like understanding of what us humans like in terms of a product, the software product that solves our problems. And one person with good product taste, maybe also with a smart way to build a brand around this. I'm confident they can create the unicorns in the future by like asking AI to build a software product, for example. And currently, we are packaging all of the things necessary to take a product to like actually work in production with payments and communicating with your users via email by just prompting. So that's what we're building right now. In the future, I imagine that we're talking to like YC companies that help you that lets you create a company for an idea with one API call, and that's also in this direction of letting anyone that knows what is a good product build a unicorn.
Yeah, so can we go one layer deeper where you have no person unicorns? The AI is the thing that just makes the unicorn and runs it end to end. And is that in the cards, like in the limit here?
I definitely think so. It's what have you thought about? What do you think?
I haven't really thought about it too much. Even the prospect of a single person unicorn seems like a lot, just because
Yeah.
you run a company and you see like how many different moving parts there are and how much coordination cost there is, and I'm sure that there will be massive efficiencies, but it does seem like it's an agentic problem, like you have all these agents that are doing things and like they're all trying to do the best work, and they need to be aligned on the same page, and it seems difficult, but not within, not outside the realm of imagination. And if you can get one person unicorns, then the step between 1 and 0 seems not as big as the step between, whatever, even 10 people and 1.
Yep. I mean, something that you're touching on here is the coordination costs between humans, and also the coordination costs between, I think, AI employees, so to say. And
yes,
and I just want to touch on that. I think people are over-indexing on that. You want AI employees and like refer to them as agents. And we've seen this repeatedly, that what you actually want is something that is more an extension of yourself. It's a tool that makes you more powerful, and almost reads your mind in what you want to do next. And I think it will look more like that than having this army of AIs that you communicate on with Slack. They will be more integrated on your computer, very close to you.
Interesting.
And then then you don't have the same coordination costs as you have with a team of humans, right?
Yeah, and there's the coordination cost with the market as well. A company is constantly coordinating with its market, and you want to make sure that an AI, whatever AI that you're using as part of your tools, is able to take that kind of input as well to iterate itself and to improve in the product that it's building and distributing.
Yeah, I see.
And one thing that you mentioned right before the call as well is like a world where software does that or AI does that. It constantly is modifying itself. It's looking at the world around it. It's trying to do self-improvement. What does that world look like? Like, what is the limit of this thing actually working?
Yeah. So I mean, just some axioms for me here is that I don't think us humans are that special in like our intelligence. I think we have a lot of there's training data, and then we have some smart brain architecture to be very good at using that training data. But what we will see is that AI is going to be as good as us, and then it's going to be able to modify, like understand its own software, which us humans we really don't. Maybe sometimes we
Mm.
think we understand our own psychology, and also understand its own hardware and be able to like, change that on a quite a short time scale. And then once that time scale is short and it becomes better at modifying itself, how like the development that we see is very very unpredictable. You might see that there is some like very hard to improve intelligence after you get reach a certain limit, but looking at like evolution and how fast it was for humans to just like become smarter than all other species and just like be able to wipe them out at will. I think that we're just like in the beginning of this trajectory of
Mm.
intelligence, and that we're going to see like some potentially some crazy fast development once you hit that like recursive self improvement. Um, the the reason yeah, at least that we can reach very fast development. The strong argument that this will not happen is that we don't want that. As humans, will just realize, no, wait a second here. This is too. This is not going to increase human flourishing. This is going to create like so fast change in the world that us humans will go crazy, or it's going to we're not going to be happy. So yeah, there is some uncertainty that exactly what will happen. I know I think it can become crazy fast development. Some people at OpenAI, I think they predict Dyson spheres within 2 decades with kind of quite a high probability, which is like
Wow.
technology that gathers all the energy from the sun.
Yeah, yeah.
And yeah, I'm kind of more on that side of this spectrum.
Does this recursive self-improvement, does it make you hopeful or does it make you fearful?
um, it's very clear that this could be like the best technology or the worst technology we invent, and the reason it's could be the worst technology, I think, has more to do with what us like which humans control the technology and what competitive dynamics are at play as this plays out, as the technology improves, and less about the technology itself, right?
Mm.
But overall, I'm pretty hopeful. I think it's going to go well. The
Okay,
risk that
so
it doesn't
hopeful
is
with
a bit scary.
a dash of fear, basically,
Yeah.
depending on can humans control it, which gives some that definitely gives some words of caution to it. So I wanted to end with a few rapid fire questions, and we touched on some of the themes on some of these before, but I'm curious. One, what advancement in AI are you the most excited about?
I think it's an application, so the possibility for humans to use AI to understand other humans' perspectives better. That could
Mm.
probably decrease a lot of conflicts and just accelerate us towards a better world.
And do you think that's the next frontier in AI research, or the next frontier is actually going to be something different than that?
So the frontier in terms of technical advancements, I think it's robust reasoning. Well, if you solve that, then the agents will actually work, and that
Mm.
could solve most other problems.
If you could debunk one myth about AI, what would it be?
Okay, I think related to what we spoke about now, like that humans will continue to be smarter than AI in some way, and I don't think that's true.
Hmm. Yeah, spicy opinion. And finally, we've left this to last, but I think we've circled around it. Is what does AGI mean for you?
Okay, so yeah, it's good with a useful definition here, and the one I like, which is very pragmatic, is at the point where if you're hiring a remote employee, that like they will just work with you over text, let's say. An AI remote employee is always going to be better, and I think
Mm.
that makes it more clear, like what is actually AGI. Um,
Eh,
so that's
Is
yeah,
that
my
across
definition.
any profession? So across any profession, if you were to hire remotely, the AI will
Yeah,
be
I
better than
think
any
if
human.
could give a long answer, I would probably remove some things from that, like salespeople, where the human connection is important.
I
I
don't
would
know.
remove
Yeah,
that.
yeah, yeah. I don't know.
Uh,
I think sales might be
um,
the first to be automated. We'll see.
well, yeah. I mean, sales that becomes more and more a question of if you have the network already, and
Hmm.
that's
Hmm.
harder for an AI to have. And the other thing, like generally, what we can monopolize as humans is that I can relate much better to you, Eric, because I know you're human. Than I can relate to like chatting to ChatGPT. I can't relate to it, and then I don't want to talk to it in the same way.
Yeah, that I'm actually I'm not sure if empathy isn't something that AI can't crack. So one of
Yeah,
the studies I've heard was that they had both real doctors and AI tools come up with notes to give to patients, and the notes from the AI were rated as much more empathetic, had better bedside manner, were just
yeah.
generally rated higher than from the actual doctors. So who knows? Maybe we'll have more of a human connection with an AI system than with other humans in the future.
Yeah, might be. I I just the knowledge that there is a human emotions there is something that
Mm,
gets me, but
right.
otherwise I
Yeah.
think you're right.
Well, thanks, Anton, for the conversation. I thought it was extremely fascinating. I think you're building really cool stuff at Lovable, and I encourage everyone to check it out. I certainly will right after the call, and really appreciate your time today.
Yeah, thank you, Eric. I had much more fun than I thought I would have. And if you want to check it out, it's currently only by invite that you can get access, and there's a long wait list. But for
Okay,
people with specific use cases, we are open to fast tracking. So uh, don't be disappointed when you see that.
awesome. Yeah. Well, thanks, Anton, and good luck on everything, and we'll be in touch.